conference. Today I'm going to talk about machine learning operations, and this talk is basically all about my experiences in deployment of AI applications. So I will be sharing how we develop and then deploy, and what are the challenges and how to encounter them, and how to use the best practices in the industry for the AI projects. I have my email here as well. If you want to contact me or if you have any questions, you can please forward me on this provided email address. So whenever we talk about state of AI projects, if we see the last decade, most of the focus is on developing these machine learning models, and one can say it's all about the AI architectures and how we can solve the AI problems. But when we talk about today, most of the times it's about proof of concepts. Those POCs, it's believed that 53% of POCs make it to the production, not all of them. And by end of 2024, Gartner estimate that 75% of organizations will shift from piloting to operationalizing or deploying these AI projects. So it's all about how you deploy them and the governance of of those products or projects into the industry. So when we talk about these, we want to have some examples, and this is one of the examples which we recently have developed, and that is about intelligent transportation. We call it Safe City, a smart city in Islamabad. So what we did is we get the video image from the camera of these some vehicles of the road situation, and from this what we do is we detect the vehicles in the frame. That is where are these vehicles. This is done by computer vision. AI algorithm actually detects those vehicles automatically, and from these vehicles what we do is we actually extract the number plate using the optical character recognition, the OCR. So this actually helps us to not only provide the number plate or the license plate of that vehicle, but also these AI models give us the make, type and color of the vehicle. So this is the output, the license plate is GS779, the model is Hilux AN10, then the type is Vigo, so and the color is black. So this is what our AI model has predicted. So what we do after this detection of the AI model, we fetch the data from the national registration. One is the taxation portal, the other one is national database of ours in Pakistan. So we get the data. Once we fetch the data, what we get is we actually get the actual information of the person to whom this vehicle is registered, and then we also get the number plate, the vehicle make and model type of that thing. So from this what we do is the detected vehicles, you can say those which are being detected and which is in the database, we match them, and if it's a theft vehicle we give an alert to the authorities. If there's the registration, the rego of this vehicle is not there, we also provide the alert. If there is some abnormal modification into this vehicle, we also provide alert. So making this system, this AI model into this whole big workspace working in continuous tandem way, we need to deploy the solution in a way it works, and it works 24/7 with the accuracy. And for making that thing to work 24/7, we need to have some practices how to operationalize this product. So this next we show this is the graphical user interface, where you can see the red box where we detect the vehicles. We call it region of interest, and from there we detect those vehicles. We also count the vehicles, how many vehicles are there, so we can actually estimate the congestion of the road situation of that. We have multiple cameras, and importantly we keep the record, the timestamp of the vehicle, when it is seen, on which camera it is seen, if this vehicle is a normal vehicle or a vehicle from the database of a theft vehicle. So from that onward we provide the alerts. So this is on the ground. We also have deployed one of the solution on the aerial vehicle, that is some drone that is flying on Islamabad, and you can see in this video we are detecting different vehicles and we are tracking them as well. The camera is moving, so from this we can also track some of the abnormal activity of the vehicles, or we can also estimate the congestion. So this complete solution is provided to our Islamabad authorities of safe city. So how this happens? We get the feed from the camera which provide us this information of the environment information, and from there we fetch this data to the safe city or smart city Islamabad servers. Once we have this data, there is our solution which is deployed there. It actually extract the vehicles, get the number plates, and then provide the results back to the server. And with this this deployment infrastructure helps the authorities to not only find the theft vehicles, to find if the vehicle is registered, not registered. It also helps them to see if there is a congestion on some signal. So this sort of all business sort of output is very valuable to have a very smooth traffic flow as well. So this example is I quoted this example because in my next slides I will go through all different areas of machine learning operations and see how developing this solution, then deploying it on the infrastructure, on a bigger infrastructure, how this actually happens and what are the initial ingredients for that. So deployment is important, as I was saying it before. Publishing a machine learning or AI model is not enough. Managing the published AI model is the important step as developing them. So for that there is always a common challenge because once you develop some solution, you have a different environment, and deployment environment is different because the tools, libraries, and the computer specs always differ. And importantly, another thing is your data is growing all the time. So to scale it up to different data set, you need to keep a track of how the data is changing, how your model is performing. So you need to benchmark your data and its result as well. And again scalability, it's not about running something on academic server. It's about scaling it to multiple servers, and deploying this solution from industry perspective is one of the important steps. So for that in industry or in academia, the term which is coined is MLOps, that is machine learning operations. So it constitutes of three important steps. One is the ML part, the second is the dev part, the development part, and the last one is the operation part, how to deploy it. And it's all about collaborative and experimental in nature. It helps to automate most of the steps, and it also helps to improve the machine learning AI models continuously. And again as I said before, it's about standardizing and then scaling it to multiple computers and environments. So MLOps in shorter term, we can say it's a DevOps for machine learning. So now I go through the project lifecycle of machine learning or AI. So it constitutes of four important steps. The first one is the scoping. Let's define the project, what you want to do. Then collect the data regarding that project. The third step is to develop the model, that is what AI infrastructure, what AI model you are going to deploy, and then train it on the data, and then perform the error analysis. Once you develop the AI model, the step which comes of crucial importance is the deployment. You deployed it into production environment, then you monitor it, and you see if there is some drift in the results, you come back to the data part, you improve your data, improve your models, and then deploy it again. So that's a complete life cycle of AI or machine learning projects. So now I will go through one by one to all of these with examples so we can understand what we are talking about. So in the scoping, let's say it's a smart city project. So we have to decide this is a computer vision project for the safe city, and we have to decide the key important matrices while sitting with the customer or with sitting with our end user. If their key matrices, the KPIs is accuracy, latency, the time, or the throughput. And then we actually estimate the resources and the timeline of the project, in what is the complete timeline to do this project. So in scoping, we actually define the requirements and then what we want to do as a solution. So once we have the scope of the project, the next step which comes into play is the data stage. So AI, we all know data is an oil for AI models. So for the data, there are few important steps which we always see. The first one is the data labeled consistently? Because there can be multiple people labeling the data, so we have to see the consistency, and then we organize the data in a way it has a consistency of the labels. Second important step is we have to clean the data as well, because at times in this case of smart city, we have a lot of different vehicles. So we have to label them if the vehicle is a car, a truck, or some other motorbike, and then we have to clean all those mislabeled data as well. The important thing here is to see the bias and the drift on the data, because at times your data the concept drifts or a data drift. There's a biasness in labeling, there's a biasness in in the cameras as well. If we're using camera at daytime, what will happen at night time? So this sort of things are one of the important steps which we have to see, if there is some bias or drift in the data. We will be talking about this thing in our next slides as well. So once we decide about the data, then comes the model development, making an AI architecture which can work on your given data set. So it constitutes your code or algorithm, AI model, then some hyperparameters what sort of optimization you're going to use, how many layers you're going to have. So you play with your hyperparameters to minimize the error of and improve the accuracy. And obviously the third part is the data, because your data actually you can use supervised, unsupervised, or reinforcement learning sort of a thing depending upon the data. If you have the labeled data for the inputs, you can use straight away the supervised learning. So I put here the three important teams here. The first one is definitely some of the research work coming from the academia for the development of the machine learning model. Then the second is the product team, because once you have developed this thing, the AI model will go to the product team, which is going to use it in the real environment. And then because you are performing this error analysis, there is also a requirement of a test team which is going to test your performance or the machine learning predicted model performance against the ground truth, which is being labeled by a human, or you might have got it from some other system as well. So you are going to do this error analysis to see how good your model performs. The last step which this all presentation is all about is the deployment, how you deploy this in a production system. So that is one thing. You get the raw data, you do the feature engineering, you get features, and then you deploy it. That in a term we call it serving, how you serve the model in the real environment, and how you monitor it, and how you monitor the data which is changing all the time, and how you maintain your machine learning model to get to that new data. So from deployment we might come back to the data or modeling as well, because if your model is not performing well in the production, we have to come back to improve our data, we have to come back to improve our architecture as well. So serving the model and then providing this governance architecture is one of the important steps while you put that solution into the industry or into the business. So there are few tools for each step. We called about data we need to do the data versioning. There is data versioning tool called DVC and many others. Then if we have a big data, we have to see Hadoop and some other sort of data lakes, data bricks sort of a solution. Once we have these big data sort of versioning and maintaining that data, Then comes the training and evaluation. The first and the foremost is like which framework you are using for your development of AI model, like PyTorch, Python, Keras are like all these libraries in the Python. What sort of a library you're using? Are you using some sort of a C or some other languages for deploying of your solution, like TensorJS as well? So with all these libraries, one has to have like the compute resource as well. There is Lambda, there is a Google Cloud, so multiple the cloud-based architectures are there to train and evaluate your solution. So all these products are there. Obviously, you will be using some some IDE like Visual Studio Code, Jupyter or something like that, and maintaining all that code base using some tool like Git. Once you have this training and evaluation, the deployment has definitely other tools as well. We call if you're deploying this on a server, that's again the cloud-based things come into play, like this algorithmia or Lambda. If you're applying it on a very small hardware, then the edge-based solutions come into place. So obviously there is TensorFlow Lite, Onyx for edge-based solutions, OpenVINO as well. And we need to have a pipeline where we develop this thing and then deploy it. So we call it continuous integration and continuous deployment. So CI/CD based frameworks are also there, like Jetkinsons and something like that. So our Circle. So we are going to discuss some of the tools here as well, like MLFlow and DVC in the next slides. So overall, once we talk about scoping that project, we have to see the diligence on feasibility, like if this project is technically feasible or not. So we have to see the data which we are going to encounter, is it unstructured data like speech or images, or if the data is structured like transaction record, like a database, and if it's a new data, we need to get that data, or if it's existing data, we will have human label on those data as well. So the important question is can a human given the same data perform the task? So we will have a ground truth against each problem. So we have to see the technical feasibility while getting some project in AI as well. And other than that, we have to see the diligence on value, if our solution from the business perspective, if it's going to provide some value like a revenue or how much user engagement we will have. And then there are machine learning matrices as well, where you actually see if your model has more accuracy than the previous models in precision and recall. Overall, time plays important step as well, like latency and throughput. So having a technical and a business team trying to agree on matrices which both are comfortable is one of the important steps in while you scope your AI project. So the questions can be is this project creating net positive societal value? Is the project reasonably fair and free from bias? It's only dealing with some sort of problem which is not unethical as a way. So we have to see these two sort of diligence while doing some project. And from scoping, once we go to the data itself can be a big data or good data. So what is in big data you can have a lot of data, but it's have a lot of noisy labels. So that doesn't perform well. So here we have three pictures where we are showing if you have a small data, the left side, and noisy labels, so your model will be performing not very well because you have small data and the noisy labels. But if you have a big data and noisy labels, there is a problem. Probabilistically, the regression model can fit into the good points, and your model can perform well. But importantly, if you have small data and it's a clean, consistent data, which we talked about earlier as well, your model will perform very well, and your model can have a simple model rather than a big model. So even from deep learning perspective as well, it's not about always a big data is important. small data with clean like data points is important as well. So we always talk about high quality data in all phases of machine learning project lifecycle. Then, like, when we talk about development, we have said, like, the AI system is basically based on your code and data. So your algorithm or the model which is actually being developed for this AI problem, it's basically the code, and then the input is the data. So there are, like, two sort of you can say these the point of views exist. One is data centric and the other one is model centric. In the model centric point of view, it's about, like, you collect what data you can and develop a model good enough to deal with the noise in the data. So it's all about model. You perform, you actually play with your hyperparameters of the model, and you improve your architectures. You use some sort of a NAS where you search your architectures, neural architecture search sort of a thing, and you improve your model. And your data is basically fixed. You iteratively improve the model while the data remains fixed. So that is generally what is happening previously. That is about model centric view. But what happens now is we talk about data centric view, where, like, the consistency of the data is the paramount importance. You use tools to improve your data quality. Like previously I said, small data and clean data. This will allow multiple models to do well, and then you can get the simple model which actually don't need that much resources in the production, and you hold your code fixed and iteratively improve the data. That's like, where we are going right now, is data centric view of, like, developing those models. Now, like, before deploying it into the environment, we talk about like experimental tracking, like, because we have to validate, we have to reproduce the results. So what to track about? One is the algorithm or code versioning, like Git. Then dataset used, we have to like, keep track of the data versioning as well. The hyperparameters might be I'm using, like, some sort of a decision tree, and the depth of the tree is one of the hyperparameter, and I change that depth to get more good results, and then I change it to someone where I am not getting good results. So I have to keep track of these hyperparameters as well. And obviously the result is one of the important thing which we need to keep track of. So there are tracking tools as well, as I said before, and the desirable feature for these is, like, you need to have in-depth analysis of your experimental results, and it obviously helps you to monitor and visualize all those errors which are happening in the different versions of the models. So in the deployment, like, now after all that tracking, development, and the data steps which I talked about, the key challenges in deployment is, like, you can have two sort of things. One is the concept drift, and the other is the data drift. Let me give you, like, the computer vision example, visual recognition example. In the training set, you have a historical data of different objects and data from a few months ago. So how has the data changed? We have to see, like, if the things with the objects in this data, if those objects are changing, and new objects are coming in, like new cars, new models are coming in, we can say actually the problem has drifted in a way, like, we are talking about concept drift. But as far as the data drift is concerned, it can be, like, different weathers, different time, and all that, like, the biases in the data that comes into this data drift thing as well. So after that, like, it's all about software engineering issues, because it's this conference I was seeing, like, it's AI and the software and the robotics. So all these software engineering issues come into play while you are deploying some predictive service or predictive solution. So if your solution is real time or batch based, if it's a cloud or edge based, what are, like, compute resources which you require, the latency and the throughput, do you need any logging or black box logging, importantly security and privacy, or those issues where, like, you have to encapsulate those all your machine learning AI models across that. So these are one of the important players once we talk about deploying those solutions. So coming back, there can be different deployment patterns. In our safe city, we started with a shadow mode. In the shadow mode, machine learning system shadows the human, like it runs in parallel. Machine learning system output not used by any decision maker, but we sample the output and verify if our machine learning is predicting true or false. So it's we can say it's sitting across there and with the human, and we are getting the human output and then seeing if our model is performing better or not. The second deployment pattern which we use is Canary deployment. That is, we roll out the small fraction, say 5% of traffic initially, monitor the system and ramp up ramp up the traffic gradually. We started with 5% of the cameras, and then to scale it up to, let's say, 100% of the cameras, we do it in incremental way. So with this, what we can do is we can see if there is any issue in the scalability, we will not face a clear failure. We will have incremental updates, and then we can scale it up to the complete environment of the production. This is one of the important deployment as well. We haven't used it, but generally people do it. It's a concept you have the input image or data, and it goes to the router, and the router if you are going to change your previous model, we call the old or previous model is as a blue version, and the new and green version is it's the new model. If might be I got my new data in the deployment and I changed my model, I improved my model, and got a good accuracy on the training data. Now I want to see how it performs in the deployment environment. So one thing is I just go there and change my model altogether and see how it performs, but that's not a good approach. So generally what we do is we put the old model there, and then we put aside the new model as well, and then we benchmark these old model and the new model and see if the new model is performing well, and we need to go back and roll back all that thing. So with this it's always easy, you switch to the new model and then you change the old model and keep on rotating it. So in terms of your product in industry, in business, your user will not encounter any sort of a bottleneck where your model is not performing well, and you roll back to some previous models. So this is one of the important feature of once which sort of how you incrementally update your models, called blue-green deployment model. So, and importantly, once your model is in the deployment, you have to see the monitoring as well, your server loads, the fractions of outputs, if their data is missing. So you have to brainstorm these things that could go wrong, and the statistics and matrices that detect this problem. It is okay to use matrices initially and gradually to remove the ones you find not useful, and then this monitoring and evaluation helps you to improve your models, and then use all those deployment models which we talk about, like green, blue sort of a thing, Canary, or shadow mode as well. So some of the tools which we are talking about, you need to have a versioning of the data, because your data set is improving and it's increasing as time goes on. There is one very good open source tool called DVC, data versioning control, and one can use this thing for the versioning of your data itself. It integrates very well with the Git. Git maintains its own hierarchy of the data as well. So it's one of the useful tool. There's another important tool which generally we are using is MLFlow, which actually maintains the whole life cycle, where including the experimentation, reproducibility, deployment as well. You can serve different models all together using their model serving API, and then they will have also have the model registry. I have, let's say, 10 models. So I have a registry of those 10 models, and it's up to me which sort of model I want to use. So it's all about staging that model, then putting it in a production, then archiving that model. So as I said before, your blue, green, you need to have 2 or 10 models, 20 models, and how you update those models in that this MLFlow plays an important role. Then the last one is the CI/CD, where generally you are deploying your solution on a cloud or in a real environment. You can use containers for the Dockers or Heroku or Jenkins. These are one of the good CI/CDs environments where you can use good DevOps practices. Makes the deployment pipelines more manageable and more easy. So these are generally the tools which are being used in this whole deployment scenario. So in last machine learning in production, when I say machine learning in production, it's all this talk is about AI and machine learning projects. And then machine learning model development is a very small part in all these things. So POC to production, there's this gap. This machine learning model is is also you can say clustered with all these software engineering sort of things, where you have to see how you configure, how you do the data collection, then the feature extraction, verification of the data using that machine learning model, then using software engineering like resource management, tracking of the codes, analysis, and then serving those infrastructure like MLFlow, and then the monitoring. So in short, the requirements surrounding the machine learning infrastructure is of importance as well. That's why whenever we talk about MLOps, we say it's a DevOps for the machine learning. So it's a software engineering coming close to this machine learning and helping it out to produce a really reliable solution. So in conclusion, what I want to say is we have to see the agility of the solutions, the continuous and the faster deliveries, the faster modification, how we can fix the bugs. We need to have a solid the experimentation method as well, where we have faster and control experiments and experiments to control and to do it in the other environment as well, to see the scalability of your solution, easy integration into the new machine learning models, and lower operational cost. If you are deploying it to the bigger scale, you need to think about lower operational cost. And then obviously time to market. If you are producing a new thing, you need to have reduced time to the market. And obviously then the last thing is strong collaboration with your end user or the businesses for whom you are developing this thing, and improve these whole solution by monitoring and evaluating. So in overall this MLOps is a key to producing all the academic research to the businesses, to industry, and using all these practices can help to have a reliable and good efficient solution. With this, I would like to thank the conference organizers for inviting me. Thank you so much. Have a very good this conference, and I'm looking forward to all of the questions if you have any. Thank you so much. Bye bye.